Welcome to Business Statistics with Dr. Quesada. Today we will have an overview of what statistics is, why is it important, and some applications in business. A proper understanding of statistics is critical in any business today. Statistics is a science that starts with the collection of data. We design instruments such as surveys or polls, or just use observations as our data collection method. Another way to gather data is by using secondary data that is already collected by somebody else. Under data collection, you have to worry about your sample. How big does a sample have to be? Is it representative from the population? Is it a random sample? Then, once we collect the data, we must know tools that help us analyze it and interpret it. This is where many of the tools learned in this class will come handy. After all the technical analysis, you must be able to translate those results to a plain language that people who don't know about statistics can understand. So we don't use jargon here. And finally, present your findings, analysis, and explanations in a professional way using data visualization. The presentation of results is best when it is eye-catching and not full with raw data. Let's dig into statistics now. There are two different areas in statistics. One is descriptive statistics and the other one is inferential. You probably are very familiar with descriptive statistics. We see them all around us, on the news, in sports, everywhere. We have graphical and numerical statistics. In graphical statistics, we will use particular graphs based on the type of variables that we are presented with. For example, qualitative variables, also known as categorical variables, are better represented using bars or pie charts. Categorical variables include colors of cars, age ranges, gender, job type, transportation modes, and so on. On the other hand, quantitative or numerical variables allow us to make deeper analysis. They are numbers that you can average or obtain standard deviations from. We usually use histograms to see the shape of the distributions as graphs for numerical variables. Some examples of these variables include salaries, diameter measurements, and even Likert scales, like the ones we use a lot on surveys that range from completely agree to completely disagree and so on. But we will cover more examples of these later with applications. For now, let's look at the numerical descriptive statistics. This is where we summarize our data in tabular ways and we obtain either frequencies for categorical data or mean, median, and mode as central tendency measures. Remember that the mean would be just the regular average, the median would be the value in the middle, and the mode is the value with a higher frequency. On the other hand, we can analyze how the data is distributed by analyzing the variability measures such as the range, the variance, and the standard deviations. Finally, we have inferential statistics, and this course focuses a lot on this area. We use inferential statistics when we cannot measure every element of a population, and so we obtain a representative sample to make conclusions about the population. Reasons for not using the population values include feasibility, maybe not enough time or money to collect all the population values, or for example, in quality control tests, the unit is destroyed during the tests, and hence you definitely cannot destroy all of your production and you need a sample. When you summarize information from a population, you call those measures population parameters, and it's easy to remember because PP, population parameters. And these are mu for mean, P for proportion, sigma for standard deviation, sigma squared for variance. On the other hand, when you summarize information about a sample, we call these measures sample statistics. And again, it's easy to remember, SS, sample statistics. And these include, but not limited to, X bar for average, P bar for proportion, S for standard deviation, and S squared for variance. Let's take a closer look at popular continuous probability distributions in business. The shapes of these distributions are determined by both the central tendency measures such as mean, median, and mode, and the variability measures such as the standard deviation. I will start explaining the effects of the central tendency measures. In the first case on top, we have a bell-shaped distribution, a symmetrical distribution where the midpoint equals the mean, the median, and the mode. All three are equal. We know this type of distribution as a normal distribution. The one on the bottom left is a negatively skewed distribution. It is skewed to the left. In this case, the mode is higher than the median, which in turn is higher than the mean. An example is the scores on easy tests. Most students will get higher grades and very few will get lower grades. Finally, the one on the bottom right is a positively skewed distribution, or what we call skewed to the right. As you can see, the mean is higher than the median, which in turn is higher than the mode. An example is the income figures in the United States, where the higher incomes is of the few in the population and the majority of the population will be on the lower end. After seeing the effect of central tendency measures on the continuous probability distributions, let's see now the effect of the variability measures. In all these figures, the mean, median, and mode are the same and they are placed in the middle. However, in the red distribution, we have a very low standard deviation, which means that the variation of values is low and they are very, very close to the mean. In the green distribution, we have a little more variation of values surrounding the mean. And finally, the purple distribution is the one with the highest variation. In terms of business, we like low variations because we can improve better if a process is not all over the place. For example, in a restaurant, you have two servers. Server A has very low variation when it comes to time it takes her to bring the drinks to the customers. However, she takes a long time. On the other hand, you have server B who brings drinks usually faster than server A. The mean is usually lower, but the variation is very high. Sometimes it's 2 minutes, sometimes it's 7, sometimes it's 3, sometimes it's 2, whereas server A is always around 4.5 minutes. If you want to improve both of their times, which one is easier to improve and why? Server A is doing the same process each time. So you take the time to observe her and you can see that she takes too long talking to the bartender every time she gets the drinks. After analyzing her routine, you can train her so that she does not talk to the bartender while serving customers. And just like that, she switches her mean to a lower time and still her variation is low. When you observe what happens to server B, he is all over the place. Sometimes he stops to talk to other customers. Sometimes he does not write down the order, so he has to go back to the customers to verify the order. Sometimes he talks to the bartenders. Sometimes he just focuses and gets the order faster. Trying to improve server B will take a lot of analysis of the myriad variations in the process, and hence it is more difficult to improve. The first step is to worry about reducing the variation to make sure to standardize his process before we can even improve his central tendency measures. In this case, the mean time it takes him to bring drinks to the customer.